Hello, y'all. I wanted to look at the full version of the talk I was a part of a little bit earlier, because there was some nonsense that was spoken before I jumped in, because I was actually on the side working on my paper that I'm writing up for my measurement of the speed of light. I may actually do a talk on that or make a presentation on that or something. It's something common for, scientists and undergraduate students, but uh, of course, the flat earthers think that everybody just believes stuff and they don't realize that people actually do experiments and measure things, or they deny that fact. So, suffice it to say that while I was sitting there writing that paper, I started to hear some of the nonsense that was said, and it started to pique my interest. I was definitely wanting to hear uh, the flat earther explain. I ended up getting muted after calling out bullshit by one of the particular moderators. Some of them DM'd me and said that that moderator is notorious for being a bad moderator. It is kind of motivated me to find a different venue to speak in. So I may be looking more into getting flat earthers to come on my Discord or come on to Zoom or wherever, and we can talk here, or perhaps uh, doing more of debunking flat earth videos. So that's what I may look into doing. Thing about that is it's harder to find flat earth videos nowadays. I noticed they seem to at least it seems that they have adjusted the algorithm so that you it's harder to find flat earth stuff, which I don't agree with. I mean, it is nonsense, but I believe they have the right to say it. I guess it just so happens that there's enough stupid people in the world that if they let that the flat earth stuff go unhindered, it just scoops up a lot of stupid people or ignorant people or people that are not educated or whatever the case is. And some of them are actually smart, but they just don't have the information. Like there's some people who come out of flat earth, and uh, Ranty comes to mind. He uh, had an observation that he believed, because of course flat earth is about a whole bunch of distrust and denying evidence that's there. But he happened to have a observation of a mountain range local to him where he couldn't say NASA was lying. It was just local to him, and he was able to see and determine how tall the mountains was, and able to see that there was an actual drop off, and he got out of it. And I've seen him debunk some people, and uh, and he's pretty good, So I don't think he does it anymore. But for a while after he got out of it, he did. So rather there's some people intelligent that just don't have enough information or knowledge to utilize their intelligence. And of course, some of it is just flat earth teaches you to be stupid, really. I mean, it teaches you to think in a very poor way. Um, and some of the flat earthers teach you that just throwing a bunch of words together, multi-syllable words together, means you're smart and you know what you're talking about. And I think that's what's going on with this guy. So I want to scroll back a little bit in the conversation, and I'm gonna see what led up to me joining the conversation, and then listen a little bit after I got muted to see what happened. So here we go.
It has to do with coherent and incoherency, if I remember correctly.
I could agree
The
with that
volume seems
conception of it
okay.
for sure, and I usually
Maybe a
put
little
that
bit
forth.
louder.
In other words, if you put a line of magnets, ball magnets in a line, right, and you take a reading of it, it'll show one number. If you take those same magnets and jumble them up into a ball, you'll get another reading. It's crazy.
Yeah,
Coherent.
I would say
Yeah.
I would say you could even like give a decent analogy between that and something like light, where you can have a radiative light source like the sun that can project that um, more incoherent light at an extremely long distance. But within that same realm, you can have a laser that would project light. You would say that would be a stronger form of light, but that stronger form of light might not actually be able to persist as long as that overall radiative light from the sun.
Good example. Exactly. Right. Exactly. Coherent versus incoherent, and different characteristics. One traveling further than the other. Yep. And one
Yeah.
being more powerful than the other in
It all
shorter
has to
distance.
do with
You know, a
the
laser
field
could burn.
geometry.
Well,
It all
yeah.
has to do with the field geometry. Like for example, a 5 watt laser versus a 5 watt light bulb are two entirely different things. One you could barely read a book next to, and the other you can burn a hole through your ass. So the fact of the matter is not based on how much power, right? It's it's based on the field geometry, like you said, the coherency of the source.
It's
Because five
fascinating
watts
stuff.
is 5 watts. Yeah, 5 watts is 5 watts. Then why is one significantly more effective in terms of the quote unquote ability to do work than the other? You know what I'm saying? It's based on the geometry.
Yeah, if we wanted to, sorry, somebody's speaking. I might be cutting out.
You're good, bro.
Oh, okay. Yeah, kind of. If we go back to like my light analogy, if we're saying that the sun is like millions of watts and it's radiative, that's gonna give you a larger spatial footprint or a larger distance that light can radiate, or larger circumference from the source than if you have that 5 watt laser.
Yep.
So that 5 watt laser is coherent, meaning it's directing that wattage into a much smaller spatial um, footprint, and thus increasing the power of it, but it's still not enough to overcome, a radiative source that's magnitudes greater than it.
Well, it affects the capacitance, right? The smaller the
Yeah.
space, the higher the capacitance, which is
Well,
why gamma radiation is significantly more powerful than infrared at the two
correct.
opposite ends of the spectrum of light.
Yeah.
But that's the one I was going to end up talking to. I doubt he understands what capacitance means. I've never heard the word capacitance used with respect to wattage of light or anything. Let me back up.
I might be cutting out.
You're good, bro.
Oh, okay. Yeah, kind of. If we go back to like my light analogy, if we're saying that the sun is like millions of watts and it's radiative, that's gonna give you a larger spatial footprint or a larger distance that light can radiate, or larger circumference from the source than if you have that 5 watt laser.
Yep.
So that 5 watt laser is coherent, meaning it's directing that wattage into a much smaller spatial um, footprint, and thus increasing the power of it, but it's still not enough to overcome, a radiative source that's magnitudes greater than it.
Well, it affects the capacitance, right? The smaller the
Yeah.
space, the higher the capacitance, which is
Well,
why gamma radiation is significantly more powerful than infrared at the two
correct.
opposite ends of the spectrum of light.
Yeah, but I wanted to go back to like,
So it sounds like they have no idea what they're talking about. Yeah, capacitance, unless there's some new definition of the word or some other aspect of astronomy or astrophysics I didn't run into yet. I doubt I've run into one. I doubt they've run into one I didn't. But capacitance refers to how much a capacitor can hold. I'm not aware of that word in any way being used to refer to the radiation of electromagnetic radiation. So it sounds like these people. Interesting thing about it is these flat earthers. This is it. Like this is the pinnacle, right? So scientists, they as I've been hammering lately, they built the computer I'm using. They designed it. They designed the power grid and the power plants that feed it power. They design and build the buildings. So the testament to the fact that mainstream science knows what it's talking about is that the implementation of what mainstream science teaches works. When you look at these flat earthers, 100% of what they present is just words. That's it. So it's amazing that they still convince themselves that they know what they're talking about. And that's one reason why I was so interested in trying to hear where he's coming from, because it doesn't seem like we'll get to that part, but it doesn't seem like there's any basis in any observation or experiment, which is of course not to be expected from a flat earther. But I do often find it interesting to see what I mean, in their mind, what is it that's fueling that way of thinking? Let's keep going. But at this point, and this will pique me to want to join the conversation. It's like these people are throwing out these words that they seem to be using in ways that are not being used in that way scientifically, but none of them seem to know any better. So they're just like saying, yeah, yeah. And it's just, a bunch of nonsense. It actually reminds me of how Witsit talks. So, but it's interesting how, some people like DRTRH or Witsit become popular in the flat earth movement, and people start repeating what they say or repeating their talking points or their uh, mannerisms of speech. Um, make a little talk in the chat. Be sure to put something in there, those that's watching. But yeah, so let's keep on going.
Like the magnet example, where you're saying like, where Jeremy's saying like, yeah, but you can have a strong magnet at your house, but it's not going to affect any metal at mine, kind of scenario. I'm looking at that as like, yeah, you can have the laser at a specific point, but it's never going to reach another point, even though you have this much larger source that is radiative from like an incoherent standpoint, meaning it's not necessarily directed. You can have that reside within that larger radiative thing, and I was just trying to kind of correlate those two to the magnetism scenario, where you were basically saying like, yeah, it doesn't have to be that strong of a magnet, meaning it's incoherent in nature. It's not strong in a point source kind of way. So it's weaker, but has influence in a much larger spatial footprint than something that is point source or condensed.
Yeah,
Right.
when
Another
you were
another good one is the Crookes radiometer as a showcasing of this, being that the Crookes radiometer will process when exposed to blue light versus red light, due to the spatial variance of the blue end spectrum of light having a higher threshold of capacitance than the red end spectrum.
He goes again, using the word capacitance with electromagnetic radiation. I've never, I actually, LA, I'm a learning assistant for an electromagnetism class. So I took the class and I helped in the class, and by a very good professor. That class was very good. He had a lot of demonstrations where he brought in uh, various devices where he demonstrated what happens when you put a current through something. He demonstrated the induced electromagnetic fields, the induced magnetic fields, like all of these things were given practical demonstration. There was demonstrations on optics. The last part of that class is optics, and we was able to see several demonstrations on refraction of light, refraction through different mediums, Brewster's angle, and so on and so forth, including capacitance was a very big deal. Not only what capacitance is, but also how to combine capacitance in the circuit and so on and so forth. And I never remember hearing capacitors being utilized in any way that they're giving service to it. Let me see if there's some kind of other definition of it that I'm not aware of. So I'll search capacitance. Right. Capacitance is the capability of a material object or device to store electrical charge. Right. So yeah. So when you talk about electromagnetic radiation, the blue end of the spectrum has more energy because the frequency is higher. Excuse me, the frequency is higher and the wavelength is smaller. So, uh, uh, yeah, it just seems like they're destroying words together that they think sounds big. Uh, I was trying to actually get an explanation, but currently on that server, you know, depending on who's the moderator there, you're not allowed to speak freely and call bullshit when you see it. So I may just focus on trying to debunk videos more, where I can speak freely. But at this point, is not looking good as far as his word usage, and this is where I started to really get interested in the conversation. I might have tried to join sooner, but I was having some kind of mic issue. I don't know what's going on with my mic, but it seems like every other day I gotta fix it again. But so far I'm seeing yeah, capacitance property. So I'm right now looking at Britannica, and actually let me share this site that I'm looking at here. A moment. Hmm. I should let me copy it there, but I guess not. I'll just open a new tab on this one. That should work. All right, capacitance. So capacitance, property of an electric conductor or set of conductors that is measured by the amount of separated electric charges that can be stored on it per unit change of potential energy. So as I said, capacitance, and they were talking about, light, which is electromagnetic radiation. It was talking about magnetism. So they definitely are speaking on the subject of EM. And then they mentioned the word capacitance, but they're using it in the way that science does not give service to. Um, you know, so let's go back to the talk and see what other dirt comes out.
Thus allowing that procession to take place.
And
And
I'll
it's
I'll
all
catch this
about
whole statement right
Yeah,
there.
it doesn't have to be that strong of a magnet, meaning it's incoherent in nature. It's not strong in a point source kind of way. So it's weaker, but has influence in a much larger spatial footprint than something that is point source or condensed.
Yeah,
all right.
when you were
Another good one is the Crookes radiometer as a showcasing of this, being that the Crookes radiometer will process when exposed to blue light versus red light due to the spatial variance of the blue end spectrum of light having a higher threshold of capacitance than the red end spectrum, um, thus allowing that procession to take place. And it's all about the field geometry and capacitance, not the quote unquote ability to do work in the sense of energy as
Yeah,
portrayed by mainstream.
yeah, which that disparity is causing the movement. It's causing the motion in the same way that high and low pressure systems will affect one another, causing the movement through the pressure mediation. The same thing's kind of taking place there. What is what you're saying, right? It's there's a there's a discrepancy between the two phases or the two pressures of light, if you want to define it that way, and that discrepancy between the two causes the motion. You have something that moves from one to another, high to low.
when you used light as the analogy, that made
It amazes me that people who are flat earther or globe skeptic types, whatever it may be, seem to believe that they have such a great handle on these things, but it still amazes me that they can't seem to connect their lack of real world application of this supreme knowledge they believe they have with whether that knowledge is really valid. Like for instance, let's take Albert Einstein. A lot of times the flat earthers try to throw him under the bus, saying that they misquote him saying he doesn't say the earth moves and all of this stuff. But he's looking at relativity. I'm aware of an experiment that they did where understanding Einstein's relativity, they waited till a solar eclipse. And what they calculated or hypothesized was that because of special relativity and the curvature of space, light coming from objects on the other side of the sun we will be able to see the curvature of that light as that light bent around the gravity well of the sun. And they were able to see that. Another thing is the revolution of Mercury. So I know flat earthers, another thing they get so wrong, they will say as a straw man to try to uh, bolster their incredulity argument. You know, the argument is based on incredulity. I just don't believe that, or you can't trust him. They try to paint the celestial objects and their movements as some kind of random thing. I'm sure you've heard it before. Spinning, twirling, tilting, and moving at 80,000 miles an hour, and then we're moving around a galaxy. You know, they try to make it sound so fanciful. But for instance, with the solar system, I haven't really studied like galactic movements a lot, except I know we go around it like 100,000 years, some kind of long thing. With the solar system, the revolutions of the bodies are very well approximated by Kepler's laws. You know, so basically, like the revolution of a planet, it is basically, if I remember right, the period squared equals the distance cubed. The distance being the average distance from the sun cubed. If I remember right, is the average or uh, uh, the average of the long and short lengths of the ellipse that it goes around. But suffice to say, it's p squared equals a cubed. And so, you know, he looked at planets and studied them, like Kepler and Brahe and those. And so my understanding is Kepler utilized Brahe's notes because he took such meticulous notes over so many years, and he was able to come up with Kepler's laws such that we know the p squared equals a cubed. We know that if you look at the orbit of a planet around the sun, we know that the area, like if you was to track the orbit of a planet, that that planet will sweep out a certain arc in the sky. And when it sweeps out that arc in the sky, that arc will make a certain area with the sun. So you can say that this is the arc. And I figure at the top is the arc, and the triangle is the area with the sun being down here. So that's like a triangle made by the sweep. And what they found is if you study the revolution of the planets, when the planets are farther away from the sun, they go slower. And when the planets are closer to the sun, they go faster. But it balances out in such a way that get, if you take an integral of the area that it sweeps out over a certain period of time, it always sweeps the same area. So let's say if you look at Earth's rotation around the sun, and let's say the Earth moves this far in a certain period of time, and there's that area. But when it's close to the sun, it moves really fast, so it sweeps out a bigger area. But in the same period of time, the area it sweeps out is exactly the same. And then there's another law. I can see if I can remember. There's three. I forget the third one. But there's the p squared is a cubed. There's the arc, and the area swept out over a certain amount of time is always equal. And what is the third one? I'll just take a moment and see if I can remember it. Sometimes it comes to me. Or I could just look it up. But I mean, it's not a big deal. You can look up Kepler's laws. But I just say that to say that is very well understood. The difference being that Mercury had a precession that was not expected, right? With this understanding. But when Einstein came along and he took into account the fact that since Mercury is so close to the sun and therefore so close to the gravity well of the sun, relativistic effects start to impact it a bit. Now we're able to calculate the precession of Mercury perfectly, taking into account relativity. So these are the kind of things that show us that mainstream science is on point with what it says. Another example is one of the outer planets, I think it was Neptune. I believe it was Neptune wasn't discovered yet. And but what we were able to do is see a perturbation in the revolution of Uranus. So what happened is they did the math and calculated the perturbations in the orbit of Uranus could be explained by another planet being outside of that orbit that's tugging on it because all the planet, everything in the universe tugs on everything gravitationally. It's just the effect is reduced by 1 over r squared. So the farther away it is, the less the effect is, but everything is pulling on everything else. So every planet does have an effect on every other planet. So they calculated there must be another planet there. They pointed the telescope where they calculated the planet should be, and voila, we found a new planet. So therefore Neptune is found, and you can look it up. I'm pretty sure it was Uranus and Neptune, but I'm just going off of memory right now. But the idea is there. You could look it up and find it. But I say all that to say that everything that science accepts as a law, as a theory, has these practical implications. Not to mention, even when we're talking about capacitances, if we didn't understand how capacitors work, we wouldn't have a computer. If you open up your computer, and I'm not saying break your computer, but I built a computer before. My computer before this one, I built it, and so I was able to, see all the different workings of it. And if you have a motherboard of a computer, you can see the capacitors on there, right? So if we didn't understand capacitance, we would not be able to build computers. Computers, capacitors are an integral part of computers. So when I hear this guy talk about the capacitance of blue light versus red light, it's just like, what in the world? But capacitance is a property of an electric conductor or a set of conductors, unless he could, as you can see, related topics, the Farad electrical conductor, alternating current circuit. Nowhere in here do I see any relation to electromagnetic radiation having some kind of capacitance. It just makes no sense unless you could point out. I mean, what did he take graduate physics that I didn't get to yet that talks about that? I doubt it. If he thinks the Earth is flat or not a globe, as he says, so it's amazing. But what I find is that the flat earthers don't seem to, or maybe they're unwilling to make the connection. I was telling my dorm roommate yesterday how a friend that at first I didn't. I was like, people can't really believe this, but I knew he wasn't lying to me. This guy I knew, we met over video games, and he fell into the flat earth. He's still a flat earther, as a matter of fact. And but he could not seem to bridge the gap between the real world implications of what he's believing, and the lack of real world implications of all these beliefs, even though if what he believes is true means all of science is wrong, even though all of science, all of our technology and real world devices are based upon that understanding of science. So it just amazes me that flat earthers seem unwilling even to understand that. And the reason why I say unwilling is because we were having a discussion, according to flat earthers, all of the videos from space are fake. And we were looking at a SpaceX launch. I don't remember if it was live or recording. And you notice how flat earthers, part of their thick is to ask a question, but it's not an honest question. They think they're debunking you, they're asking a question. And it's a question that anybody who has even a basic understanding in science or even willing to think know the answer to. But they're either unwilling or unable to think about it. And they just delude themselves in believing that asking a question means that they debunk something. So my friend did this. We were looking at the video, and there was a little camera pointed to the rocket booster. In the back, you can see the planet Earth lighted. And he said, well, if it's in outer space, where's the light coming from? It's supposed to be in outer space. Now, to me, it was patently obvious what it was, but I didn't tell him. I just asked him, okay, if the planet is a globe, and if the rocket is really in space, where could or would the light be coming from? And he got quiet for a while. And then he said, sort of uncertainly, oh, the sun, it could be the sunlight. And I'm like, yeah, you can see the planet behind the rocket is lit. Obviously, it's on the daytime side of the planet. But before he thought about it, he just decided that the fact that there's light is some kind of fakery. But he's intelligent enough to think about it because I didn't tell him the answer. I just encouraged him to actually think. And just a few seconds of thought, and he realized, oh, okay, it could be sunlight on the rocket, and just like sunlight is on the Earth. So that tells me, and I mean, he's not mathematical or scientific, but he's an intelligent guy. Like I said, we met over video games, and he used to figure out some things in these video games that was amazing, you know? So, but it seems like when it comes to the earth, he's unwilling to think critically. And that's what it seems to be going on. It seems that people are unwilling to honestly think about these things. And instead, they're more willing to insert their own delusions about it, which is stuff that they just make up. That, you know, as we're seeing, is showing to bear no, has no bearing on reality, you know, and the real understandings of things that, again, like I said, make our technology work. If it didn't, if the understanding was false, then we wouldn't have computers, for instance. Let's keep on going.
Sense because you have inverse square law of attenuation as well as the inverse law, the square law.
Yeah.
So when you use that as a picture, that makes sense to me.
Now this guy here, I guess I haven't barely been motivated to speak to him because I mean, going in to talk to flat earth people, there's a certain amount of dirt you're going to have to deal with. But all at the same time, there's a certain level of dirt that just seems to me like I'm just not willing to engage in. Like usually when I'm talking to a flat earther and they start going into stuff like the guy was saying yesterday, well, have you actually been to the sun to know what the medium is like? That's just silly. And I just let the conversation go. I mean, that's just, and just in case, because I know there's some flat earthers watching this, uh, just in case I'll address it for you all. Um, like for instance, if you're at an airport, right, and they're waving in an airplane, do the flight controllers in the tower like get a ruler out and like run out across all the different climb over houses and run all the way out to where the plane is at, and they get a big giant ladder and climb up to where the plane is at and put the ruler to the plane to measure how far it is from the airport. Did anybody ever see airport tower technicians climbing over everything to run under the plane to climb up a tall ladder and put a ruler to it? No, they use radar. This is basic. They use a radar tower to point a radar at the planes, and then they know how far the plane is. They know where the plane is, so they can direct the plane to land. It's silly to believe that today we need to literally physically go out to the sun to know what the medium is like between here and the sun. Just like we don't have to go to an airplane with a tape measure to know that the airplane is, you know, 50 miles away or whatever it is on this vector. And so we know that we need to tell that plane to hold off a bit because another plane is about to land, and so on and so forth. It's silly. It's absolutely silly. And that's why I have those who were listening to that conversation yesterday. That's why I just didn't say anything because I'm like, this is just, it's just, why should I have to explain this to a grown adult human being? And to today's age, it makes no sense. So it seems like I was saying about my friend, in that moment, I didn't need to tell him, dude, the sun is in outer space. Sun is on the rocket and on the planet. Is apparent. All you have to do is be willing to think about it. So I really think for people who say that are just unwilling to think rationally and critically. So that's why I just let that go. But maybe I need to stop doing that for the benefit of people who are watching and actually hash it out. Because I learned the hard way, like when I was debating Wotan and he was saying silly stuff. And sometimes I did that. He would just say something so silly. I would just be like, I mean, the average person can't fall for that. The average person has to know that's silly. But then I went back and watched the debate and was looking at the live chat, and they were still people like, "Ooh, Wotan is getting them," and he said something like, "You know, have you been to the moon? Have you been to the moon with a tape measure?" It's like, what the hell? Yeah, how do people fall for that? But they do. So maybe I need to get out of that habit and even, you know, go into it with even the lowest level of dirt, I guess. I don't know. But with this guy, I didn't. I just let him talk. He was saying stuff about ether, and I would just like I had no inclination to talk to this ether guy. So let's keep on going, and eventually we'll get back to the guy I ended up talking to.
To me, and also when it comes to coherency and the opposite of being incoherent in electricity, when you have phase alignment, you have coherency. So you have two oscillations, and if they have the same phase, we call it coherent. So in the sense of a physical magnet, and you line them up, you're creating in-phase relationship. So you can have a physical coherency, electrical coherency, and they're doing the same thing. So you can also have phase combined
Disparity.
with each other.
It's called phase disparity, and that's literally the same effect when observing the double slit experiment or a ferromagnetic cell. It's that interplay between those conjugate fields interplaying, being the dielectric and the magnetic.
Yeah.
Laughing because in no way do I believe this guy has any understanding of quantum mechanics and you know the double slit experiment. You know yeah.
The,
But yeah,
I guess the
And let me know how the volume is, by the way, guys. If the volume of them talking is too loud or too low, let me know in the live chat so I could adjust it. If everything is fine, it's cool. I'm monitoring it. I'm trying to keep it pretty much the same, but just in case my reading of my technology instrumentation here is not precise, let me know, and I could adjust the volume of me or of them.
the main point was that inverse square law, attenuation with light, there's coherency, but then there's also strength, and there's magnitude of influence that comes with strength, and that's.
I like what you said. Sorry, before you move on, very important. I like what you said about the wavelength light coherency, the way you explained it, like the same wavelength, like the same.
Yeah.
That was very good for people to
Yeah.
understand, right?
Yeah, that was
Yeah.
good. Hey, maybe you can explain counter space to SE.
Oh, don't even go there because we're gonna get into a beat. We're doing good. But yeah, that was really good the way you explained it. Like the way I explained the magnets in a line, all lined up as opposed to jumbled up.
Yeah.
The waves are the same peak, right? The same. Yeah, well done. I like that.
Yeah, then there's ways you can influence the phase where you can create magnification, or you can cause, which you would, in electricity you call a peak, and then you can cause a valley in electricity. When you have a decrease from the peak, and you cause that decrease, you create a valley. And mechanically, you can do the exact same thing with magnets. You can create peaks and valleys. And if you have no change and you have full and complete coherency and phase, it's like there's this unchanging event that is like a satisfied condition that that tends to not want to change. It will, like, once you create this phase coherency in electricity, it's like it's easier to maintain that once it's obtained. I don't know if that's making any sense, but getting into phase coherency is more of a job. But once there, you can maintain it with very extremely small electrical pressures that you influence it with.
You know what's freaky as well? If you have magnets lined up,
Your
right?
mother.
And they attract, right? On one side and they repel on the other, right?
Two poles, yeah.
But if you bunch them up, right? They repel. The overarching thing is to repel. That's another freaky thing.
That's because there is no such thing as magnetic attraction. That's actually a misnomer.
All right, so this is another this was when my interest really got piqued. I think I tried to talk at this point, and my mic was having issues. But like I said, I'm a learning assistant for an EM class. That's absolutely wrong. There's clearly repulsion and attraction to magnets. I mean, this is a basic demonstration in an EM class in a university. So it's amazing. And like I said, the mainstream understanding of magnetism um, is utilized in technology on a regular basis. You know, there it is electric engines that run by alternating currents and causing electric fields, magnetic fields to come into play. You know, magnets play a big part, some understanding in things like radios, like the speakers, and so on and so forth. So our understanding of magnets is demonstrated by the fact that we make magnets work in technology. So why don't we take a quick look for a magnet? We're still on Britannica. Let's see what they tell us. Mm, well, you might not be able to get to a succinct enough definition. I mean, I'm on this Britannica page, and it's like a big giant wall of stuff. But suffice it to say that if you have the two positive sides of a magnet going towards each other, they repel. If you have two negative sides going to each other, they repel. So the positive and the negative attract to each other. This is like basic. And I'm sure we've all seen the little demonstrations where you maybe everybody hasn't, but like you put the iron fillings on the ground and or on a table, and you put a magnet underneath, and you can see the field aligning the little fillings. And we also did in my the time I actually took the EM class, that class we had to do labs like this one. The class I'm in LA for, they don't have a separate lab, but the professor brings in all the devices and experiments, and like there's portions of the class where he demonstrates different magnetic properties, different electromagnetic properties. Sometimes he will ask the class, okay, what will happen if I do this with the current? What will happen if I put the magnet here? What happens if I move the wire looped around the magnet in this way? What direction would the magnetic field go? All of these different intricacies. And he might make an Instapoll where the class has to answer the question, and then he demonstrates it, and we see if we're right or wrong, and we learn from actually working with magnetism how things work. So it's clear what they're saying is patently wrong. I mean, there's a class full of freshly graduated high school students that understand magnetism better than what they're talking about. But it amazes me that they're sitting there declaring this incorrect stuff as if they know what they're talking about. Is absolutely amazing. So, and my point in joining was not so much to like it seems the mute guy was trying to get me to uh uh have some kind of rebuttal or something. I was really trying to hear his explanation of how he even comes to think about this stuff. And I believe that just like how when I was talking to who was I talking to? Um, I guess I talked to so many of them now. Sometimes they're starting to blend together. I guess a good example is my debate with me and PhD Tony was debating Allen and Toby, and he was spending all this time talking about satellites and trying to debunk it and saying what satellites do. So I asked him, okay, what's reference frame is proper time? Which if anybody who understands relativity can answer that basic question, and they had no clue. And this is the thing, so either they do have something, which sometimes they do. It's just wrong, but I do like hearing what's the how did you come to this conclusion to think that what you're saying is accurate? But but yeah, if what he's saying was true, that there's no real attraction to magnets, then our technology wouldn't be
electric
able to work.
pressures that you influence it with.
You know what's freaky as well? If you have magnets lined up,
Your
right?
mother.
And they attract, right? On one side and they repel on the other, right?
Two poles,
But
yeah.
if you,
And that's untrue, by the way. A magnet has a field coming in one side and out one side. But like I said before, if you put two negative sides together or south sides together, they repel. If you put two north sides or positive sides together, they repel. But the negative and the positive attract. That's just basically incorrect about magnets. But it's not surprising that these people believe science is wrong when they misunderstand it so succinctly. They have such great misunderstandings about what it is and base their conclusions upon that misunderstanding. And I mean, how else can you come to a bad conclusion? But again, nobody have to believe this. Like I said, in my EM lab, we did a lab, but we had to do stuff with magnets, and we just sat there for a while playing with magnets, seeing how they stick together, spinning them around, seeing how the same sides repel, seeing how the opposite sides attract. It's just basic. You know, all you have to do is get some magnets and play with them. And it's amazing that these people get this stuff wrong.
if you bunch them up, right, they repel. The overarching thing is to repel. That's another freaky thing.
That's because there is no such thing as magnetic attraction.
Hmm.
That's actually a misnomer. I know I've
No, but
talked
you know
about
what I
this
mean? That
before.
coherent as opposed
That's
to
kind of
incoherent.
freaky.
Yeah.
Sorry,
But
I think I helped you.
Daiso, if I'm attracted to the conversation about magnets, would you consider that a magnetic attraction?
No, explain that, bro. Explain how
So it's
coherent
a
versus
it's a
incoherent
conceptual.
magnetism.
Oh, sorry. Repeat it, Essie. Go ahead.
Oh, go ahead, bro.
Oh no, you sounded like you wanted to hear something else other than how magnetic attraction doesn't exist. So just curious.
I don't know. You're kind of low, bro. I'm having a hard time hearing you.
Oh shit.
Speak with your
Can
chest,
anyone,
Daiso.
can anyone else hear me? Is it me or him?
Sounds like a little boy talking.
I hear you fine.
Oh, okay. Thanks, Q up. So yeah,
Sorry, I'll put you up, bro. My bad.
it's a false idea based on the mutual acceleration of magnets towards one another, which is a false concept based on faulty observational acuity. So it's actual acceleration.
I
No,
hear you.
yeah,
I'm hearing you.
Oh, shit.
Speak with your
Can
chest,
anyone,
Daiso.
can anyone else hear me? Is it me or him?
Sounds like a
I don't know. You're kind of low, bro. I'm having a hard time hearing you.
Oh, shit.
Speak with your
Can
chest,
anyone,
Daiso.
can anyone else hear me? Is it me or him?
Sounds like a little boy talking.
I hear you fine.
Oh, okay. Thanks, Q up. So yeah,
Sorry, I'll put you up, bro. My bad.
it's a false idea based on the mutual acceleration of magnets towards one another, which is a false concept based on faulty observational acuity. So it's actually this dielectric acceleration towards counter space. Magnets likewise accelerate towards one another, rather towards this lowest pressure point, being this vortexal center between the both. And this is the same phenomena that so-called gravity and likewise electrostatic cling are. They're all three one and the same expressions. The only one difference being an attributional difference between the so-called gravity and magnets mutually accelerating, that being that magnets are a point source. So they're not additive rather than multiplicative objects, whereas gravity, the phenomena is a non-point source mutual mass acceleration towards the same lowest null pressure point vortex center.
Does anybody watching? It's my first time that I remember recently, at least, seeing this guy. Um, can anybody know for certain that he's not trolling? Like that he's really serious? I mean, he seems serious. But I mean, what does any of that even mean? like I said, I sat with an entire semester with two experts at electromagnetism already that could bring out demonstrations that show all of these different phenomena in detail. You know, magnets, currents, induced currents, biomagnets, you know, capacitors, resistors, the combinations. You know what happens in a circuit with a pin parallel in series with this resistor, with this many capacitors. You know, all the different variations of basic understanding of EM, and nothing he says falls within any of that. We can't take anything out of what he said and build something. It seems like just a bunch of nonsense. Um, I suspect that it's some kind of influence from Witsit because I've looked at Witsit talk and I've seen him do this. He seems to just throw a whole bunch of big words together, and it's just nonsense. It like has no bearing. Anybody who has even a base, like I said, I'm not an expert, but I have an undergraduate understanding of it, and you know, and even that, I mean, it was a semester ago. I'm starting to get rusty on it now, but I know enough to know that that was just a bunch of nonsense. He says it with such gusto. It goes to let me see if I can pull up the MC Tune, I believe, has the rules of pseudoscience. Let me see. It reminds me of that. Uh, all right, here it is. Uh, characteristics. All right, so I went to MT Tune site, 11 characteristics of pseudoscience, and it opened up this site. So let me put this on the screen after it loads. Here we go. So this is the site here. One is unfalsifiable. Yeah, that certainly sounded unfalsifiable. But there's one in particular I was looking at. So here's the image. Professor Certainty talks of proof with great confidence. So we can hear him talking with great confidence, but just like how we looked at the definition, the actual definition of capacitance, and how what he's saying doesn't have any relation to the actual definition of capacitance that is utilized to build all the technologies that we have that use capacitors, like cell phones, computers, and so on and so forth. Uh, uh, what are you saying? All that Google goop you just said about magnetism has no bearing on anything I've seen in two very good uh, 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 university classes about uh, you know electricity and magnetism. Now, one of the things they might say is, "Oh, you just believe in them." But it's similar to what I said to QE. I talked to QE one time, and that reminds me, I got to find that video. I have it somewhere. Um, and he was talking about the classic second law of thermodynamics means that you can't have an atmosphere. And one of the things I asked him was, "Where did you learn about the second law of thermodynamics from?" Right? Because you can't reasonably say everything that science says is wrong. Then where do you how do you even come to the understanding of the words second law of thermodynamics? And I asked him, what did he say he learned it from school, from university, right? So then the next question is, okay, if you learned it from university and what you're saying is different from what they're saying, why should I listen to you when you're wrong compared to the people you learned it from? But I couldn't even get that far because he started to interrupt me, asking questions like I asked him at the time. Like I said, at the time I didn't really. This was in between the time when I now I went back to school. I brushed up, but this was I didn't go back to school yet, so I really didn't know. So I asked him, what is entropy? What is a macro state? I was wanting him to tell me, and he didn't know. I mean, so he's throwing out these words, macro state, and entropy, and second law of thermodynamics. I'm like, what is a macro state? And he gave some bullshit. Eventually, he gave some bullshit definition. But what I did was I pulled up the website that he linked as his reference, and the website, which gave the real definition, contradicted what he said. So he didn't even have a clue what he was talking about. He was just throwing words out. And then I started asking him, where did you learn about this stuff from? Well, I learned about it from school. So you learned about it from school. Oh, well, anybody can learn about it. And, and he started to trail off, and then he just stopped, kept interrupting me. Similar to how they did on this channel here. They muted me. I don't remember where we were talking at, but he wasn't in a position to mute me. So he just kept over talking me, and he wouldn't let me. And I told him, I said, it seems like you interrupted me. You're not wanting me to ask a question. Well, I don't agree with your interpretation. And I just left because it was clear to me that he didn't want to. And again, I wasn't asking gotcha questions. I was just asking real questions like, what does entropy mean? What does microstate mean? And I really didn't know. He just couldn't tell me. And the link he gave contradicted that. It started to fall apart, and he just didn't want. We didn't want any more. And his method was to interrupt me. So, but again, this same thing applies. Before he actually had the answer to what he was saying, he was speaking with such certainty. He was speaking so boldly and so sure about himself, and he just knew what it was, but he did not have a clue. So that's the same thing I'm finding with these guys. They're speaking so with such confidence, but they have no clue what the hell they're talking about. And I think the way flat earth works is usually with people who are ignorant. Like when I say that, I don't how I mean in that harm is I mean it's just a fact. If you don't know something, you're ignorant. If I don't know something, I'm ignorant of that thing. But the thing about flat earth, all of them are ignorant. That's why they flat earthers. So it's like a bunch of ignorant people saying a bunch of silly things to each other, but none of them know any better. So they just accept it and think it's smart. It's sad sometimes, man. It just seems sad. Let's keep going.
And magnetic repulsion, rather than additive, like polarities forced in close proximity, have multiplicative force manifestations due to the compounded ether torsion, where rather than force dissipation, force is multiplicative in the most basic definition of unnatural. So only this phenomena actually is actual magnetism in action, since so-called magnetic attraction doesn't actually exist.
So again, what technology is built based upon the idea that magnetic attraction doesn't exist? What law of physics can be observed that's based upon that? Again, we able to calculate the revolution of Mercury with relativity. We're able to find new planets with gravity. What technology, what discovery, what anything can you point to based upon your understanding? Nothing. The definition of capacitance that I linked is what built this computer. What is built with his understanding of magnetism? Nothing. It's crazy.
Gotcha. So pressure mediation. So if we were to put a magnet while it's tracting in a pressure chamber, right, to measure, would we measure a difference in pressure?
All phenomena is based on temperature and pressure mediation. There's no phenomena you're going to get away from that doesn't have that included.
I'll say that one more time. That's another thing I want to jump. And I think I was still having mic issues here.
So-called magnetic attraction doesn't actually exist.
I think I went back too far. Hold up.
To measure, would we measure
That doesn't have
difference in pressure?
all phenomena is based on temperature and pressure mediation. There's no phenomena you're going to get away from that doesn't have that included.
He said all phenomena is based on temperature and pressure mediation. So how does temperature and pressure mediation keep the particles of a molecule together? How does pressure and temperature make an electron go around an atom? I mean, this just makes absolutely no sense based upon basic understanding of natural events. Um, how does pressure and temperature make lightning? I'm not aware of pressure and temperature having anything to do with lightning. I guess you could say temperature makes the clouds come, but I'm not aware because we talked about lightning a good bit in this EM class. I don't remember anything dealing with temperature and pressure. It was a imbalance of charges. I could be wrong about the lightning thing, though. I got to look into that. I'm not sure about that. But definitely, there's phenomena that outside of pressure and temperature. I mean, we have what's the four basic forces? What we have: gravity, the strong, weak nuclear force, electrostatics. If I remember right. Uh, yeah, it's crazy. Let me four forces. Let me make sure I note that clearly. I don't remember that one off the top of my head myself. Yep, gravity, weak force. Okay, well, I wasn't so far off actually. Oh, well, I did have it. So let me share this screen here. Four fundamental forces of nature. Uh, and I got this from space.com, but I just remembered it from, they talk about this in, like, for instance, my astrophysics class. That's what a memory of it came to mind when I was in my astrophysics class. We have to take a lot of this stuff into account when we're like observing distant stars and galaxies and quasars and whatever, you know, like when we're doing spectra, when we look at that spectrum, we might have to take into account, we have to, the electrons and the atoms and the particles, what's going on with them. Because the spectra that we perceive is going to be based upon the energy levels that the electron, jumps up and down on. And when that photon hits that electron, there's an energy transfer, but it's not because of pressure. So it's wild. But the four fundamental forces, we have gravity, we have the weak force, uh, the electromagnetic force. I think I said electrostatics or whatever, with electromagnetic force, and the strong nuclear force. Uh, some people think that vaguely I remember in my astrophysics class that some people think we might find another force in dark matter or dark energy. Maybe there's another force we can find that's allowing them to exist. But I'm not sure about that one. But as you can see, these four fundamental forces are not based upon pressure or temperature. They're unique fundamental forces in themselves. And again, the technology that we have, like for instance, gravity. Gravity is buildings are made with the understanding of gravity because we could, make sure we have enough material to support the building or bridges, you know. Um, my understanding of the weak nuclear force and the strong nuclear force is not as strong. With electromagnetism, I mean, definitely we dealt with that. Dealing with in the EM class, the electromagnetic, like Coulomb's law and things like that. So let me look into that section of it a bit, the electromagnetic force section. And again, this is at space.com, the four fundamental forces of nature. He said there's only two, but there's four. Neither of them are pressure and temperature. But the electromagnetic force, also called the Lorentz force, acts between charged particles like negatively charged electrons and positively charged protons. So I'm reading this paragraph here. Opposite charges attract one another while like charges repel, which is what I said earlier, right? I said if you have a magnet and these same charges repel each other, the opposite charges attract. And just what I said earlier. So these people are patently wrong about just basic, fundamental scientific things that you could just look up. How long did it take for me to find that? It didn't take me long at all. And again, I just remember it from my physics class by a real physicist, who understands this stuff. So as you can see, what he's saying is just wrong. It's just wrong. And again, this is not something that you just believe. Look into. So what does it say? Looking at this paragraph here, the electric component acts between the charged particles. Hey, what's going on, Earth is life? So they wouldn't let me talk in the chat, so I decided to come here and look at the entire thing and give my commentary on it. Since I guess depending on who's the moderator in the chat, you can't talk freely there. But I'll probably just start doing a lot more debunk videos where I could talk as much as I want. And I might talk to Gio about just getting on a little panel thing with Slow. Where we just going through the talk, and some of the things I probably would have ended up debunking live if I wouldn't have gotten muted there. And looking at this paragraph here, it says the electric component acts between charged particles whether they're moving or stationary, creating a field by which the charges can influence each other. But once set in motion, these charged particles begin to display the second component, the magnetic force. The particle creates a magnetic field around them as they move. So when electrons zoom through a wire to charge your computer or phone or turn on your TV, for example, the wire becomes magnetic, which is what I was hinting at earlier. So, our understanding of these things, like an example, one of the descriptions they did, I say description, I mean, one of the demonstrations they did in my EM class, the professor took some wires and was running different currents through them because, we had to learn theoretically what direction a magnetic field is induced when a current goes through a wire. And you can put these wires together, like two different wires together, and alternate the currents and see how they repel or attract according to the field that is generated, the magnetic field that's generated within them. And the professor did that demonstration in front of class with different wires, and he was able to alternate the currents and see how they either repel or attract. It's pretty cool. So I say that to say that if I mean, I guess that example is reversed. Things like that, people actually doing experiments with things. That's how we get our understanding, and then we apply their understanding to technology, and that's how the technology works. So if these people try to apply this understanding to build something, it's not going to work. So it's just quite amazing, man. It's quite amazing. Let's go ahead and keep on rocking.
But so we will measure a pressure difference if we put a magnet in the chamber and let it attract or repel.
I wouldn't say that to be the case. I'm not talking about the environment rather than the field itself, which isn't the environment.
There's really no way to prove what you just said.
Well, no, I guess
He called them
you
out.
could say that when
Let's
you're
hear that one more time.
measuring.
I think I forgot that part.
I wouldn't say that to be the case. I'm not talking about the phenomena you're going to get away from that doesn't have that included.
But so we will measure a pressure difference if we put a magnet in the chamber and let it attract or repel.
I wouldn't say that to be the case. I'm not talking about the environment rather than the field itself, which isn't the environment.
There's really no way to prove what you just said.
That's pretty good. If what you say is you can't get away from pressure and temperature, then it should be some kind of pressure or temperature thing that happens that you can measure. So
Well,
that
no,
was pretty good.
I guess you could say that when you're measuring.
Do you understand additive versus multiplicative?
Absolutely.
So, Essie, if you wanted to put a measure to something and you get some sort of reading, whether it's electric, right? That disparity would technically be a pressure. Like that would be caused by a pressure. So even an electrical input or a reading there is going to show you a reading of pressure. So what Daiso is saying would kind of hold true there.
So in that sense, everything then is pressure. Any movement. There's really no way to prove what you just said.
Well, no, I guess you could say that when you're measuring.
Do you understand additive versus multiplicative?
Absolutely.
So, Essie, if you wanted to put a measure to something and you get some sort of reading, whether it's electric, right? That disparity would technically be a pressure. Like that would be caused by a pressure. So even an electrical input or a reading there is going to show you a reading of pressure. So what Daiso is saying would kind of hold true there.
These people.
So in that sense,
It's amazing.
everything then is pressure. Any movement, any form of.
It seems like they're just reaching to try to. I mean, I guess it's customary of the flat Earth word game thing. I really wonder where flat earthers. I don't know if it's particular flat earthers come up with this manner of thinking about things and others follow it, or if it's just a natural outflowing of delusional thinking where people just it's just a natural thing for them to just try to make up stuff and just make words fit together. I don't know. It amazes me.
I guess you can describe anything, right? Not exclusively to that, right?
But I see it's calling them out.
Everything is established via this pressure mediation. Yeah, I would say the kind of like the Fibonacci sequence and the way in which many things in nature can like grow to that.
We already discussed the fundamental forces. Not everything is based upon pressure.
Geometry. That geometry is substantive by the etheric pressure mediation, and that is kind of
Did you say the etheric pressure mediation?
Geometry. That geometry is substantive by the etheric pressure mediation, and that is.
I think he did say the etheric pressure mediation. Hey, what's going on, Blue? How you doing? Good to see you. Reviewing some dirt that went on earlier today. I'm gonna pop on into the stream in a moment, but I wanted to go back and like see what led up to the conversation that was being had. So it's interesting dirt.
Kind of the fingerprint of it there.
Well, look, if you want to put it that way, like there's no way for me to ask for a proof, or there's no way for you to prove it. So if you want to go in that sense, I mean, is there really
SE is doing pretty well. SE is like, where's the evidence? Well, what is the real world implications? Just like I was saying, it's pretty good.
a conversation to be had here?
Well, like he was saying earlier, with the different phases of light causing the movement within a Crookes radiometer, thus establishing, like I said before, kind of this pressure relationship, high to low. So the physical movement, there needs to be a force that causes that, and the force that causes that physical movement to take place is the disparity, like the discrepancy between the high and the low wavelengths, which those wavelengths, if it's movement, the movement would cause a different pressure. So it's just not measured in the same way that we would measure air pressure, but it's the same thing.
Mm-hmm.
I guess if you put it in those certain terms, in general terms, okay.
Hello.
That cause, thus establishing. Well, like he was saying earlier, with the different phases of light causing the movement within a Crookes radiometer, thus establishing, like I said before, kind of this pressure relationship, high to.
Let me look up a Crookes radiometer. I'm not familiar with that. This I actually like Britannica as a site, by the way. So it says, a radiometer is a 4 Van Mill. A radiometer is a 4 Van Mill that depends essentially on free molecule effects. A temperature difference in the free molecule gas causes a thermomolecular pressure difference that drives the vanes. The radiometer will spin if enough air leaks into the gas envelope, right? A Crookes radiometer consists of a glass bulb from which most of the air has been removed, thereby creating a partial vacuum, and a rotor that is mounted on a vertical support inside the bulb. And I'm going to click into this part here. Oh, is this the one? Is infrared for detecting measuring radiant energy. The term is applied to a particular device used to measure infrared radiation. Radiometers are of various types that differ in their method of measurement or detection. Those that function by means of an increase in the temperature of the device, such as Herschel's thermometer, are called thermal detectors. Commonly used thermal detectors include the thermocouple, which produces a voltage when heated, and the bolometer, which undergoes a change in electrical resistance when heated. Devices that can in principle detect a singular quantum of radiant energy, called a Blackwell's photographic plate, are called quantum detectors. The photoelectric cell is the basis of many current quantum detectors. The term radiometer is often used to refer specifically to a type of detector invented by Sir William Crookes in the late 1800s. And I'm scrolling to here. It is rarely used as a scientific instrument because it was found to be insensitive and not easy to calibrate. Interesting. But it paved the way for the more exact instruments they use today. Let's read that again. The term radiometer is often used to refer specifically to a type of detector invented by Sir William Crookes in the late 1800s. It is rarely used as a scientific instrument because it was found to be insensitive and not easily calibrated, but it paved the way for the more exact instruments in use today. So this is quite interesting that the argument seems to be based upon technology that's very much outdated, which is pretty to par with flat Earth. Like I remember we was having a talk the other day, and the guy was talking about how astronomers said that they, use the solar cycle to produce predict eclipse, and that's what it's based upon. It's just astronomers said it. I say, well, astronomers also say that the Earth is a globe and the moon revolves around the Earth. And it revolves around the sun. Like, do you accept that now? Since astronomers said, well, those are new astronomers. That's recently. So apparently, the old astronomers, what they say is more valid than what the new astronomers say. I guess because they part of the conspiracy. I guess, right? But I don't see the flat earthers like going around in a horse and buggy because cars are new technology. That's not. I mean, that's new technology. Why are you using the cursed new technology? Why aren't you walking or using a horse and buggy? Why are you using cars and airplanes and internet? That's new technology, right? So it's kind of like they want to pick and choose what new stuff they want to use. Uh, uh, and but the other stuff is the stuff that's new that contradicts the ancient beliefs they want to hold. Something they sometimes have to throw that away. And Blue says that the Crookes radiometer can be bought on Amazon. See what that looks like. Yeah, interesting. So it looks like it's almost like a what do you call it? Like the decorative item, like it's like uh what what do you call those items? I can't remember the exact word, but there's like a keepsake or something like that, like something you put on your counter as like a interesting thing for guests to look at when they come by. Uh, but according to what I'm reading here, it's not a serious scientific instrument anymore because with the things we have today is a lot more sensitive because, as it says here, it can't be calibrated well, and more exact instruments are in use today. So you know being that flat earthers so often base their understanding on old knowledge. Like I remember I was talking about the eclipses, and they were talking about ancients talking about Rahu and Ketu, you know, even though we could actually see the moon and we have satellites orbiting the moon, so we know where the moon is, we know how far and distant the moon is away from the earth, so we know when they're going to be annually eclipsed and so on and so forth. But instead of accepting that, they accept that some strange thing happens when the moon suddenly gets in front of the sun and is really Ratu Kehu, if they even get that far. Some of them think it's just not the moon at all, and it's amazing how they do. I'll read a little bit more of this. A Crookes radiometer consists of a glass bulb from which most of the air has been removed, thereby creating a partial vacuum, and a rotor is mounted on a vertical support inside the bulb. The rotor bears four light horizontal arms mounted at right angles to one another on a central pivot. So that seems to be what we saw there. The rotor can turn freely in the horizontal plane, which is what we saw. At the outer end of each arm is mounted a vertical metal vane. Each vane has one side polished and the other side blackened. So that seems to also be what we saw here. When radiant energy strikes the polished surface, most of it is reflected away. But when it strikes the blackened surface, most of it is absorbed, raising the temperature of those surfaces. The air near the blackened surface is thus heated and exerts a pressure on the blackened surface, causing the rotor to turn. All right, so that's simple enough. So I can see why he wants to talk about pressure and temperature, but it's still wrong to say that pressure and temperature is involved in everything. Like we saw earlier, the four fundamental forces, none of them were temperature or pressure. Um, you know, even though I mean, you could argue that a magnet can, if you put paper between two magnets and you put the positive side and the negative side so that they attract, which is of course contradicting what he said about there's no attractive forces in magnets. there'll be pressure exerted upon the paper because of the force, the magnets pushing against each other. But it's not to say that the magnetism and the attraction is because of pressure. It's an effect of that. So they're just getting a lot of stuff wrong, and it seems like they're basing their position on outdated technology, which further explains how they're getting stuff wrong. Let's keep going. Oh, and Blue says it's really just a toy. That's right. That's the word I was thinking about. Blue, novelty, a novelty item. That's the exact word I was thinking about. Blue says it's a novelty. It's really just a toy, a novelty item. If you shine a light onto it, the little wheel spins. That's all it does. Yeah, so that makes sense. So it's an old novelty item that you put on your counter for when guests come by or your little kid can play with. But it seems like they're trying to elevate this device to some kind of high stature because it's old, based upon my understanding of flat earthers. So we'll see if they talk about this some more. If in a moment they're going to start talking about dark matter, and that's when I start to jump in. Let's see if they say a bit more about this.
Low. So the physical movement, there needs to be a force that causes that. And the force that causes that physical movement to take place is the disparity, like the discrepancy between the high and the low wavelengths, which those wavelengths, if it's movement, the movement would cause a different pressure. So it's just not measured in the same way that we would measure air pressure, but it's the same thing.
I guess if you put it in those certain terms, in general terms, okay.
He heard counter space and he automatically just said, "Fuck that."
Yeah, absolutely. I'm counter space. You know that, bro. Don't try to counter space me, bro. You know that. You got to prove your stuff, bro. I don't care what side you're on. You know how I am, right? So
Well,
I'll
that's the
definitely
problem.
push back.
That's the problem. Is this counter space isn't an empirical, demonstrable, provable thing in that sense. It's it's non-quantifiable, bro. You're asking for something that's metaphysical and non-physical, and wanting me to physically prove something that's not physical. It's like impossible. It's
I'm with you,
antithetical to
bro.
the possible.
It's God territory. Creator.
Well, as you think of it this way, if we did it in terms of like the way that
And
they
let me
want to
know if
do
I
it
should
with
adjust let me know if I should adjust the volume on anything, Blue. If the speaker should be higher, if I should be higher, or vice versa.
antiparticles or these what did Dirac derive? I can't remember what Dirac called them. But anyways, they have these positive and these particles and antiparticles. Kind of the conception of an antiparticle, if you want to quantize counter space in like a increasing negative way, like a reduction from the reality in which we live in into the counter spatial, from the material to the
Awesome,
immaterial,
thanks.
from the physical to the metaphysical. If you want to say the further you get into the metaphysical, we can meter that in form, like a mathematic form of a negative, and it works with all of our equations. Would you agree with that sentiment? As a
Well, yeah,
definition of it?
you don't try to like as long as you don't try to give this a physicality and absoluteness, right? Because the quantum people do the same thing, right?
Well, it's actually the antithesis of physicality. It's the
Well, they
opposite.
have an anti.
Oh no, now you're starting to lose me again. Talking about quantum, I heard mentioned at some point they were saying quantum is sort of made up stuff when we know that's not true. That's a whole another discussion. I'm less versed in quantum, but I do know that, for instance, the sun wouldn't be able to have its fusion reactions if it wasn't for quantum, and that the part of the way that the some of the particles that combine to make fusion, the number of particles, if any of them, wouldn't all be able to fuse if it wasn't for the fact that there was some quantum tunneling going on. And one of my professors was able to show us the derivation and how that was calculated. It was like a side discussion. It wasn't like a main part of the class, but sometimes they do some interesting things. And he was just pointing out some of the things that quantum effects are integral as a part of, and how fusion and how the sun works is integral to that. And he was showing he had a diagram and everything about the basically the like sort of the well through which the particle had to go through. So it's kind of like in quantum physics, the barrier that they have across is almost like a potential. And if a potential is infinite, then the particle can't go through. And if the potential is anything less than infinite, there's a probability that the particle will get through. And the lower the potential is, the more probability the particle would get through to the other side of the barrier. So basically, the way it works is the potential is such that particles of a certain energy can traverse the barrier, and if it wasn't for that tunneling possibility, then the fusion wouldn't be able to happen. And we wouldn't have a sun and life and all of that good stuff. So um, again, I mentioned earlier about how this stuff that they say science is wrong about, the technology we have wouldn't work. But now they're talking about things that several fundamental processes of life wouldn't occur if it wasn't for quantum processes that we understand. So these people get so much stuff wrong, but are so ignorant about it. It's amazing.
Hold on, they have an anti-neutrino. Did you know that? There's a neutrino and there's an anti-neutrino. So they have a particle, and each particle has its anti-counterpart. See what I'm saying?
So
They use dark matter and dark
is it
energy.
negative 0.008 EV?
I don't know about that, but like I'm telling you, they have that counter thing. Like you guys are talking about counter space, they have a counter particle, bro. Like I'm not making this stuff up.
You enter
Check
the
it.
field of dark
Anti-neutrino.
matter and dark energy, and if somebody were to try and describe a logical or a empirical stance on dark matter, dark energy, they're going to lose me right away because
Good one, Blue.
it's just,
It's just too bad we don't have an anti-SE.
to me, it's
I could
just
give you an answer.
fantasy. Just
Well, I guess to a certain extent, understanding science, anybody who understands science is an anti-SE. I guess in a sense, I actually like SE. I think he's cool. But we've talked before in the past, and he actually came on my RTS show here and debated Sean Hawkins one time, or maybe even twice. He debated Sean Hawkins, and he was getting a lot of basic science stuff wrong. Like according to him, if I remember right, he said that when a helicopter went into the air, it should be, way down laterally because of the spin of the Earth. And it seems like he did a calculation based upon the rotation of the Earth, the how fast the Earth rotates. And he took that calculation at that latitude and said that the helicopter should have moved that far. So it seems like he has no understanding of conservation of momentum. So there's a lot of basic things he misses, but of course that's to be understood with flat earthers. But I like SE.
fantasy. And
I'll tell you what dark matter is.
This is the part.
Oh, here comes a dirty joke.
No, I can't do jokes anymore. I get in trouble. But dark matter is just a term invented by quantum relativists to refer to the ether. By their own admission, it's called dark because it's completely unknown and dark to them. And finally, matter because they think everything is matter slash atoms. And to a hammer, everything's a nail, and to an atomist, everything's is matter. So in short, so-called dark matter is a cryptic euphemism to get around the mention of ether, which even the priests of quantum admit is at least 70% of the entire universe, if not more.
No, wrong. Some of you may be aware that I did a talk on dark matter and dark energy in my astrophysics class. Um, the majority of the grade actually was based upon writing papers, and I'll see if I can find this paper while I'm telling you about it. I mean, not this paper, but my presentation. But the majority of the grade was on writing a paper, and we had to write two papers. He had a list of topics we can choose from, and we had to pick the topics we wanted. So I picked dark matter and dark energy. So, of course, I'm not an expert, but I did spend, I guess you could say, half a semester researching dark matter and half a semester researching dark energy. And we couldn't just do like the flat earthers doing, just look at a meme. You had to actually read a scientific paper. And even though we didn't understand it, they didn't expect us to understand it completely. We had to at least understand enough of it to, get a general understanding of it to be able to explain something, which I'm sure I did because I was able to give a talk on it. So let me find that talk real fast, that presentation, and I'll share it. And I'll share a few pages of it, and we could look at where the people that were really involved in our understanding of that dark matter is there. So one moment here. All right, here we go. So let me share this. So I'll add another share. I'll add a window capture. We'll call this PowerPoint. Oh, there already is a PowerPoint thing. Let's see. All right. And nope, not that view, that view. Okay. So like this is the talk, this is the screen from the talk I did on MC Tunes channel. And which is the last talk I did. So I actually gave the talk at a college. A college is about 4 hours away from here. I gave the talk at, so there's this New York conference company that I give talks at before. I gave a talk on the Course of Miracles there a few years before, and then I gave a talk there on dark matter last year, and I gave this talk on MC Tunes channel. I think I might have gave the talk at a fourth place as well. Oh, you know what? I'm thinking also gave the talk for the what do you call it? Directed me reading program. I dovetailed that with the directed reading program at my university, and I gave a talk there. That was a very short talk, like 15 minutes. But all right, so these are the main people: Fritz Wicky's Jan Ort, Vera Rubin, Kent Ford, and Douglas Close. So the first one that comes to mind is Vera Rubin. So what she did was uh, she realized that observing the gas clouds in Andromeda and other galaxies, she realized that the velocity curve of the galaxies was greater than the matter we can see. So basically, what she found was she observed it and was able to calculate the actual velocity curve of these galaxies, and she was able to see, like if you look at this, if you was to look at the amount of matter we can see in a galaxy, the amount of matter of gas would account for this amount of velocity of rotation. The disk itself, which should include, if I recall, the planets and stars and everything, should give us this speed of rotation. And the halo of dark matter needs to be included for us to have this velocity. So this top line here, this is the actual velocity that we see when we look at a galaxy. So she was one of the first ones to properly identify that dark matter is really there, in part because her partner in crime, Ford, built a new spectrometer. So at this period of time, the technology to record these things was not as advanced. And he actually made a spectrometer that was able to get more accurate readings. So she was able to get a more accurate accounting of the velocity and throughout the galaxy, and be able to account for the velocity curve. So and basically she used these gravitational equations, which should harken ideas of Newton, and she was able to. And by the way, she's not a quantum physicist. So these people are just wrong. They're just wrong all the way through. They're wrong. Now let's see what Blue said. Uh, we could have called it, we can't see it and we don't know what it is, but it behaves like matter, but that's hard to say, so dark matter is much easier. Exactly. So it's basically matter that we can't see like we can normal matter, but we know it's there because of the gravitational effects. Vera Rubin is one of the main ones who was listed. Then we get to Douglas Clow and those guys. The bullet cluster is one of the main observations that I like because they was able to see the plasma as the majority of matter in this galaxy cluster. But if you look at the focus of the gravitational lensing, is where all the stars and everything at, which is where the dark matter would be focused. So these people are just wrong through and through. These people are not particle physicists. They're not particle physicists. So not only are they wrong about what they say dark matter is, but they're wrong about who they say is the main names in dark matter. These people are not particle physicists. So these people are just wrong. Now, there are particle physicists that's coming into it. Like I believe I talk about the particle nature of I read about the particle nature of dark matter a bit. Um, Let me see if I mentioned that. I guess I don't mention that too much because that was a difficult topic. But this is the one of the most fundamental problems in modern astroparticle physics. So particle physicists are starting to get into it because now we get at the point where we want to find out what is the particle that makes up dark matter. So the particle basis of dark matter is starting to come to fruition, but it's definitely not a situation where uh you know it's some kind of quantum misunderstanding. Yeah, that's just absolutely wrong. So again, these people have no idea what they're talking about. But the idea that they're speaking is what it did pique my interest. I was, because like the talk we had yesterday where a guy was saying, what was he saying? Um, Let me think. Oh, he was asking about the when I was saying how we know the distance to the sun because we bounced radar off it. And he was saying he was asking how far how far did the planet Earth move in between the time we sent the radar to the sun and then the radar came back? And having dealt with flat earthers enough, it seemed to be a dishonest question, a delusional belief that he's debunking something. So I asked him, what's the purpose of asking this question? He just asked the question again. I said, no, I don't want you to ask the question again. What's the purpose? It took about 10 or 20 minutes for him to finally answer, to in some way let me know that he thought that it was something that disproved that it was wrong, that it couldn't work. I asked him, are you aware that the people who did the experiment wrote papers? They wrote in detail what they did. I think it took a while for answering that too. And then finally I asked him, why didn't you read it? Are you going to read it? And he said he is going to go look into it, but the question is, why didn't they already? So I believe that these people don't want to know. They don't want to know. So that's why they don't read these things. They would rather hold on to their delusions about what it is so they can maintain their belief in the flat earth rather than actually going to the source themselves that has the answers to these questions that they could just find the answer to, you know? Rather than just saying, why does that happen? Well, how did they do that? Literally go to the people who did it and see how they did it. And then you will know how they did it. But again, in their mind, it's fake. So asking the question is somehow some kind of disproof. I don't understand how people think that way, but that's the way it is. So now we're getting into the dark matter part. I just showed how what he said just now is wrong.
Yeah.
And by the way, be sure to go to MC2's channel and watch that talk.
It's like Lorenz's explanation and interferometry result, trying to excuse bending of space and time,
I
shrinkage.
don't think I agree with the explanation, Dyson. There.
Oh, you don't think it's 70+% of the entire universe comprised of dark matter openly admitted by your camp?
Nope, that's not what I'm disagreeing with. What
Oh,
I'm
okay. Which
disagreeing
part?
with is you're saying that
Dark life matter?
the priest came up with it to not have to admit to quantum. I think that's
No,
wishful thinking.
it was.
Whatever
You
it was,
misspoke.
yeah.
Yeah.
Okay.
Omnivore's getting them.
I mean, why do you say that?
Because I don't think I don't think that's what's going on in any of their heads.
That's fine. So give me a concise explanation on dark matter. I'll be waiting.
Okay. You'll be waiting?
Yeah, because I think
Oh.
you're hard pressed to give me something that's a concise explanation.
Oh,
on dark
I'm
matter.
sure that whatever explanation I give you won't be sufficient, but I think that's part of
He's right. Whatever he says, they're just going to deny it anyway.
that's built to make the conversation.
We'd like
no
to
matter
hear
what I say. Well,
Don't give
I'm
it the
gonna
world. Go
do
ahead.
it.
Go ahead and explain
just-
it.
we have the ad. We use the ad hom horn on you, Omni.
Well, when I get a bad faith question, I'm gonna call it out.
That's what I was just talking about. Bad faith questions. It's customary in flat earth.
Go ahead Go forward. Hold on.
So,
Just go ahead and explain dark matter then. If it's not sufficient for Dyslow, he'll let you know, but go ahead and explain it.
so the dark matter phenomenon is that we see gravitational fields exerted on things when we can't see. There's no obvious mass creating them. There's no apparent mass creating them. So, what that means is that, and we see this along a different number of spectrums: light bending, the rotational speed of galaxies, the rotation of individual stars around binary stars around each other. There are several situations in which we see this. So there's a lot of cases where we see what looks like the effect of mass, where we don't actually see the mass. So people have said, well, maybe something is going on with gravity. It works differently at long ranges, but that doesn't actually fit the data. Okay,
so amazing how great you make it sound.
And he's actually giving a pretty good explanation. So going back to the PowerPoint there. Like here, these are some of the observations. So Zwicky was one. He utilized this telescope, the 18S telescope, to view several galaxies using the Bureau theorem. So this is an example of the coma cluster from Zwicky's paper. That's directly from one of his papers that are utilized in my paper, where he was able to look at he did more than one method: the Bureau theorem and rotations, statistical mechanics, gravitational lensing. He was the first one to suggest that, and as you can see, the gravitational lensing in this image here. I gave a little this detailed rendering of it came from the ESA, NASA, and so forth people, but this is an example of how we can see that there's something more there because there's such mass that is causing duplicate versions of that quasar to be there because of lensing. It's causing this one here to stretch. It's causing this one to stretch, and really, it's a galaxy from behind that large mass in the middle. This is an Einstein ring because of gravitational lensing. Jan Ort was looking at this cluster, Virgo cluster. So all of these things show the rotation curves that was much more than what we would see with only the visible matter, which is where this graph comes from. Like I said, my favorite one, again, the Billet cluster with all the mass that's there. So time and time again, our observations saw that there's more. And if you see these green contours, those are the lines of gravitational lensing. So just like how if you go back to this image here, oops, did I scroll the wrong way? I think I scrolled the wrong way. So if you go back to this image here, which shows this lensing here. So basically, you can see where the lensing is because of the curvature of I guess you could say the stretching of the light around that large gravity well in the middle. The same thing you can see here. You can see the little stretching of the light bending around these large gravitational wells. Those are basically images of things that's behind the gravitational well. So basically what they did was they made these contours to signify to us where that curvature was. They had to use like some high-tech equipment to find all the different lensing and stuff going on, and they put the contours there to see where all the lensing was. And we could see that the lensing is at a different place than the matter is. So he actually did pretty well in his explanation. Of course, just the flat earthers will not accept it because that's what they do, you know.
You make it sound like it's not just relativity failing by 99%, you know?
I mean, you can call it what you want, but that.
I mean, that's objectively what it was, though, right? Like, you can't disagree with that.
That's right. Blue was saying light gets smeared. It's quite interesting. Not only is it being duplicated, but I guess it depends on the specific amount of matter and how much is lensed. It depends on whether it gets bent perfectly, or it gets bent in a very skewed way. So I mean, it's quite a pronounced demonstration of what gravity can do. It's interesting.
I can't
No,
disagree with
I absolutely would
Fritzwicky.
disagree with that.
Fritzwicky went and he noticed a Como galaxy and that it was missing 99% of the mass it needed for the galaxy to stay together and not fly off into Never Never Land space vacuum area, right? So when I say your examples and your proof of dark matter is really just relativity failing, how can you argue that I'm wrong to my face?
Easy. So relativity, I'll explain it to you. Relativity is more than just cosmology. I know that everybody in this conversation, every flat Earth person on this server, desperately wants cosmology to be the only application of relativity. But alas, it turns out it's not. There are other applications of relativity that it works perfectly fine for. The only one where we're having this issue is with cosmology, and even worse for the failure camp. Even worse for the failure camp. Yeah, it doesn't mesh well with quantum either. But
so it really just works locally here.
Just a minute. If you believe in quantum, then why don't you believe in relativity? So, I mean, obviously, you're going to say it's an internal critique.
Yeah, I don't know where he gets that from. Omnivore seems to be addressing it pretty well, but what I think is going on, the fact is he's not 100% off. He's sort of touching upon the idea of I believe he mentioned the Fuzwiki in the Coma galaxy. Uh, uh, so I mean, there is an idea that the rotation curve of the galaxies is such that it needs more matter than what it has to stay together. That's not necessarily wrong, and I'm trying to find. I know there was a mention of that something to that effect in one of the papers I went through. It looks like I didn't put that exact wording in the slides I have here. I'm trying to just scroll through it here so you don't have to see the slide flipping all the time. But suffice it to say, I mean, that idea is not so off. It's just for some reason the flat earthers are, you know what I think it is? I think some level of their mind, Blue, they know that they can't address what science actually says. Just like the guy I was telling you about who was asking, how far did the planet move for the retard to bounce back? But he doesn't take the step of actually getting the writings of the people who actually did it, who say exactly, if that was an issue and how they resolved it. Why? Because they don't really want the answer, because then it'll contradict their flat earth beliefs. So I think he wants to grab onto that, because even if you tell him it's wrong, some part of him feels vindicated that it doesn't work. And of course it doesn't work because, like you said, where does relativity say that? He's making a straw man. But the straw man doesn't work because it's not what relativity says, but he can hold on to that it doesn't work, and I guess to them it's just, even if it's a delusion, that little moment of feeling like they're vindicated is enough. I don't know, is amazing.
What you can't do because you don't understand the perspective of the internal people who are talking about this. So, that's also kind of a non-starter.
So
what's going on,
Omni?
Okay.
If Einstein came out with his stuff because Newtonian physics ended up only working on the local scale, and then we find out that
I gotta agree with that.
Relativity only works out on the local scale.
False. That's false.
That's kind of interesting, right?
And that also would not actually be true. But okay.
Oh, I'm wrong again. Okay.
Well, yes, you are. But I mean,
anyone else think I'm wrong?
No.
All of modern physics thinks he's wrong. To answer that question.
Yeah, I don't think I'm wrong, Omni.
Well, that's fine. You don't have to think you're wrong. It's certainly within your your rights as an American to think you're right. No
Well,
matter
in
what.
fact, you just said it yourself that Einsteinian doesn't work. You look out far to distant galaxies on the large scale, and it doesn't work that well with quantum on the small scale, right?
I almost said the words you want to put in my mouth, but that's not what I
I'm
said.
just repeating what
You're
I heard
not,
you say.
but you're not.
If
I
something's
said
not
it
working doesn't
doesn't
mean it's
work.
not real.
I said
right?
it doesn't work well for cosmology. It does work very well for things on the very large scale, like the sun or the planet Mercury.
It's not the very large scale we're talking about, and you know it.
How is that not
Sounds like
part of
cosmology to me.
And I mentioned Mercury earlier, by the way, so you know what he's talking about with that. If you wasn't here already, just click back in the video and I'll talk about that.
Sounds like cosmology to me.
Yeah.
It's generally not part of cosmology.
It would have to be if it's not
Wait, what?
about the Earth you're standing on, right? Because that would be like geology, right? If it's
Dude,
outside of this Earth, like the sun or Mercury within your model, that's cosmology.
Yeah, the solar system, solar system and how the solar system works. If you drew a Venn diagram, the solar system, that circle would be entirely within the cosmology circle.
I understand that you think that. However, cosmologists are generally not focused on the solar system. So, sorry.
Well, that's a generalization that
So let's look at that. Let's look at that, guys. Let's look at what cosmologists say cosmology is, right? Cosmology from Britannica. Cosmology, field of study that brings together the natural sciences, particularly astronomy and physics, in a joint effort to understand the physical universe as a unified whole. The observable universe is the region of space that humans can actually or theoretically observe with the aid of technology that can be thought of as a bubble with the Earth at its center. It is differentiated from the entirety of the universe, which is the whole cosmic system of matter and energy, including the human race. Unlike the observable universe, the universe is possibly infinite and without spatial edges. So we can see that it's particularly regarding the universe as a unified whole. So just the solar system doesn't seem to be the focus of cosmology, but the universe as a unified whole, right? And Blue says the precession of Mercury is one of the really good demonstrations that general relativity works correctly, and I would agree. I think one of the things we need to do more of in this conversation is continually link the theories and laws and understandings of physics to the real world applications, whether it be everyday technology, whether it be astronomical observations. And that in itself, I think, will cause this whole flat Earth nonsense to die down. Because as we can see, we have to keep divorcing this perspective from what the definitions really are, what the technology really does, and so on and so forth. What the scientists really say, even getting the scientists' specialties wrong. Like I was showing, Vera Rubin wasn't a particle physicist. She wasn't doing particle physics. It wasn't some kind of thing made up by particle physicists or quantum physicists. It's just wrong.
doesn't mean
That
that
doesn't
it's not
refute my
within their
point.
field.
Yeah, that
Though.
doesn't actually refute what I said. The
Yeah.
solar system is indeed categorically a cosmological question.
You can claim.
Let's look at that again. I clicked the right one. Cosmology. Cosmology is the field of study that brings together the natural sciences, particularly astronomy and physics, in a joint effort to understand the physical universe as a unified whole. The solar system is not the physical universe as a unified whole. That is not cosmology.
Claim that if you want, and I don't really feel like arguing.
Well,
that.
you haven't
Prove
actually
it's not.
refuted the claim.
I'm
That's
not
like saying that optics is not
And the
within
claim is
physics
actually
because we don't deal with the
actually
physical,
So-
with light.
Yeah. Okay. All right.
One at a
so
time, guys.
yeah.
Yeah, Omni.
so-
Dark matter.
If that's your claim,
Dark
you're
matter.
just
So
going to have to
dark matter is the effect that we see. The
That's
cause has yet to be determined.
Oh, yet to be
Is
determined.
Geisler a flat earther? Geisler?
You
The
call me a
cause of
fat
dark
earther?
matter is math. That's what the cause of dark matter is.
A flat earther.
No,
I don't
it's
know,
not.
Arwen. I
Yeah,
don't know if you
yeah,
heard
it
somebody
is.
ask
Yeah,
a
it's because the
question.
math
Arwen,
didn't work out that
Arwen,
they had to create
Arwen, you
dark
there?
matter. So the cause is math.
That's
Arwen,
a
you got me
Uh,
muted or something?
What's that?
What's going on here, dude?
I'm starting to get very jumbled there, but he was making some claim about dark matter. So if you just got here, click back in the video and talk about dark matter a bit and show some slides from our presentation on that. And Blue says, I can't for the life of me figure out why anyone should discuss quantum physics or general relativity. There's some nitwit that can't figure out what the shape of the Earth is. I understand your point. I understand your point. Obviously, they don't understand the basics. Actually find it. I think my interest is largely from a psychological perspective. Right now, I'm a double major in physics and astronomy. At one point, I was going to be a double major in physics and psychology. So I still have an interest in psychology, just not as much as astronomy. But I still have a psychological interest. So I think that that is my main driving motivation, just the psychological. I just find it so intriguing. But Omnivore is actually a pretty frequent person on this server, so you know, I think he enjoys talking to him. I think he enjoys the fact that some of them do ironically wake up and start to see reason from the because stuff he's saying is pretty accurate. I mean, he's breaking down where dark matter comes from. He's breaking down that they're getting their definitions wrong, and he's breaking down cosmology is not what they say. So you saw me put up the definition of it just now. So maybe there's some flat earther who's listening who might actually look up what cosmology means rather than just believing what the people say and might say, oh my gosh, these people don't know what they're talking about. So, you may have some, but I know for me, it's just a psychological thing. And I do want to start making content more often. So it is some good content from them. But like I said, I'm probably going to start focusing on debunking videos more. I was going to make my focus joining these servers more, but if it's starting to get to the point where I'm just going to start getting muted, it's just going to be a waste of my time. So I'm just going to start doing. I'm going to start building up some other things, and spend less time there. If that's going to be the case, but I do still find it interesting. So I'm about to start jumping in. So we probably going to end in a good 10 minutes or so. So 10 or 20 minutes, I guess, by the time my part finishes, because I don't talk for too long. We'll see what it says.
Doesn't matter.
Am I muted or something? What's going on here, guys?
I can hear you now.
Everybody's talking over everybody. All right,
Yeah,
let's
this is
I
just
can hear
slow
you
down.
guys though. Maybe
Hold
we
up,
could get a
hold
mod
up,
in here.
hold up. Let's slow it down. Seems like there's
Hold up.
conversations that are taking place. Maybe I'm cutting out. I don't know. But there's a couple
No, you're
conversations
fine.
that are taking place. All right, cool. It seems like somebody was trying to get in to ask Dyslo a question. If that gentleman wants
Yes,
to go,
I,
and
I was
then
I was
Dyslo was
very curious about his dark matter perspective. Are you a flat earther, Dyson?
Whoa, that's kind of an open-handed diss, right? Like my dogmatic perspective. Well, I don't necessarily like to label myself. Um, I'm definitely not a glober. I could tell you that.
Yeah, fair enough.
Yeah.
My
How did you
dogmatic
like?
perspective is that I'm not dogmatic.
I like that.
What is
So,
the
is
I
there
basis
am
of your
totally
understanding?
dogmatic. Woof. Woof.
Daryl? Do you have an actual like question related to a topic for Dyslo that
Yeah, yes,
you want
yes.
some
I just
explanation
wanted to
on or
see where he
anything?
was coming from first. I want to ask him what is your basis for saying that dark matter is sort of really is ether? Did I hear you say that dark matter is really ether?
Yeah, it's a
What does that have to
euphemism
do
for
with
the
shit?
ether, being that there's
What is
only
your
ever
basis
been.
for saying that?
Yeah, so in the history of science, there's only ever been two postulations as to what the cosmos is predicated upon, that being ether or quantum relativity. So, being that we only have these two postulates presented in the history of science, I'm leaning towards the more factual, logical based one, being ether, instead of the one that requires more of a dogmatic belief system, being quantum
Yeah,
relativity.
now, I've taken an astrophysics class, a galaxies and the cosmos class, intro to astronomy class, or stellar astronomy class, and what he's saying is not aligning with anything. And I've also went to dozens of colloquiums where people come from different universities and give talks on the topic of specialty, whether it be detecting exoplanets or binary stars or understanding and trying to understand what dark matter is. I quoted one of those professors in my paper actually, on what things they're trying to do to try to figure out what dark matter is. And what he's saying is not correlating with any of that. So let's see where this goes. You said ether, and what was the other one?
Quantum relativity.
So you're saying that the only two things presented to represent reality are ether
That's a
and
straw man. That's an egregious
and
straw man upon what I said. I'll repeat it.
I'm trying to make sure
Said
I'm
there's
understanding. Now, let me point out something. Usually, when I'm talking with somebody and they say something, I try to ask what they said in a reworded way to see if I understand it. Like if somebody told me, pizza is my favorite food, and I say, oh, so you mean pizza tastes really good? Like let's say I'm in a foreign country and I'm like, do you like that? And they're like, that's my favorite food. Oh, so it must taste really good. Yeah, it tastes really good. Right? I'm trying to clarify that I understood what he's saying, right? Um, Now, my rewording of what he said, obviously he's saying I got it wrong. He's thinking I'm straw manning. So now what I'm going to try to do, since apparently I'm not understanding what you're saying, I'm going to try to get him to actually explain what he's saying. Since obviously I'm not understanding the words you're using, because you're saying I'm trying to straw man you or something when I'm trying to relay it back to you. Why don't you elaborate the words to me, and then we see how it goes downhill from there.
Yeah,
Go
so
ahead.
I'll repeat it. So there's only ever been two postulations in the history of science as to what the cosmos is predicated upon. One being the ether, the other being quantum relativity.
When you say what the cosmos is predicated upon, what do you mean?
How about
I mean,
God?
it's
I'm pretty sure God is has to be included if you're
That's
going
not
to
a
include
well,
science.
it.
That's
I
That's
said
not a science.
science.
What do you mean
Thank
that's
you.
not a science? It's an ontological
God
primitive. How is
God's
that
never
not
been
part of
science, but anyway.
science?
Ontology is before science.
Correct. He's talking just in the realm of science. So go ahead, Dysel.
Oh, you mean science as the religion of
Bro,
science?
Daiso's trying to
Okay,
fucking
okay.
walk.
I really don't know what happened right there. It just seems like everything just blew up momentarily.
The other guy
Darwin,
through a fucking thing.
Chill out. Go ahead,
So
Dysel.
Daryl,
Hmm?
did you hear the reason as to why I say dark matter is a euphemism to dismiss any notions in regards to conversing about the ether?
If you said it just then, I just heard like a whole bunch of people talking. What did you mean? What did you mean by what you said? That the
So what I
universe
mean,
is postulated on that, or the cosmos is postulated on that? Now remember, I tried to restate what he said to him to see if I got what he said correctly. He's like, "No, you getting it all wrong." So now I'm trying to get him to actually use different words himself to explain what he means, right?
yeah. So if we break down the history of science, right, we've got these two camps. And the fact of the matter is you've only been given one side of the story through your academic pursuits into the current connotation as to what science is, rather than the original denotative explanation behind science.
How does
I don't
dark
see
matter
how that
have any relation with
refers to
ether?
how.
Like,
Go
how does
ahead.
that work?
Can
So
we
what
get
do
a
you
You
know
can
don't
about
an
see how that
opportunity right
explains
now, and then we
how.
have a one-on-one?
Yeah, Daryl, can you please respond? Can we just get a back and forth between Daryl and Dysel for just a second, guys? Can you
I
respond to
still
Dysel,
don't
Daryl?
see how that answers the question of how you only either dark matter or relativity is like a postulate for the universe. I'm not see how that talking about the nature of science answers that.
Well, I'd start off by saying denying what you can't define is the epitome of ignorance. And are you capable of defining the ether? Has that ever been presented to you?
Notice he said denying what you can't define. I believe it's because since flat earthers always ask dishonest questions, and when they ask a question, they really think they're doing a debunk. Like I pointed out earlier, I don't think they can sometimes even recognize that somebody's actually asking a question. Like it seems like since so often they ask the question as a jibe, they think you're asking the question as a jibe when I'm really asking him a question. But he noticed he phrased it as denying. I didn't deny anything. I'm literally asking him to explain what he meant, since obviously I didn't understand because my restatement he's saying was so off. I'm literally asking him to explain it, but he's saying I'm denying it. It's wild, but again, I think it's projection. I think because flat earthers so often ask dishonest questions, that they think my question is dishonest. Let me play that part one more time. Or relativity is like a postulate for the universe. I'm not see how that talking about the nature of science answers that.
Well, I'd start off by saying denying what you can't define is the epitome of ignorance. And are you capable of defining the ether? Has that ever been presented to you before by a professor in your academic pursuit?
Is it that you can't explain what you mean by saying that the universe or cosmos is postulated on one of those two, that you keep trying to go to something else? So let's review what happened again. I asked him to his basis of what he was saying. He said something. I tried to restate it back. He said, no, that's all wrong. I'm trying to get him to explain, okay, since I'm getting it wrong, please clarify. And now he's starting to ask me stuff, right? And he's saying I'm denying stuff, but I'm just trying to get him to explain, right? So now it's like, why are you not just answering the question? Why do I need to start defining ether? I mean, how does this answer, which you so confidently stated, is the basis of the universe? How does it explain where that comes from?
What's your question?
Well, how about if
I'm
you
asking you to
define it
explain what you
incorrectly?
meant when you said that the cosmos is postulated on either, what did you say, dark matter or relativity? What do you mean postulated on that?
I mean, do you understand what a postulation
And he said predicated. I'll use the wrong word right there.
is?
No.
Why don't you try Googling that?
Right. So what I
It's
think is
like
going on is you don't know what
an
you're talking
increased
about,
level.
and
No, I think
you're
what I
not
know is
willing
going on
to
is you're
admit that, and that's fine. So we could just go on
no.
to something
I
else.
know
No,
what's going on.
hold on,
You're
hold
the
on, hold
problem
on, hold
is
on.
you're the one who
I'm gonna
doesn't know.
Yeah, before we get into who knows and doesn't know, I'm just going to go ahead and moderate. Trying to claim that somebody doesn't understand something without putting forth anything from your side, we're just going to start like muting people for a while if they continue to go down these paths of inquiry. Do you have something of substance to actually reply to him, Daryl, other than you think he doesn't understand when you couldn't even define what a postulation was? Do you have a substantive response?
I guess I guess now keep in mind, by the way, he used that word in that context, and I'm trying to understand what he means. And some kind of way they expect me to define what he's talking about. It's kind of like if I give a talk on dark matter, and I'm like, hold up, all of y'all tell me what dark matter is. Or you can't define what dark matter is. And it's like, we came to the talk to learn about what dark matter is from you, to learn about what we understand. So why are you demanding that I explain it to you when I'm here to learn from you? That's what I'm thinking. It's like, you said this thing, and I'm trying to understand what you said. So why now is it upon me to explain it to you? It makes no sense. And that's why I believe that he just really didn't understand what he was talking about, but he probably never actually, it doesn't happen often in that group, the flat earth community, but they have to actually explain what they mean. They just make up stuff and just run with it. So I think he's just trying to get away from it, which is common, which is a common thing. And Blue says a great deal of the time they don't ask questions, they ask gotchas. Very good point. Those dishonest questions. And maybe that's why he thinks mine is a denial or something. I'm literally wanting to understand what he's saying. Keep this in mind. I guess I'm used to hearing, like,
Do you have
let's
something
go
of
back a bit.
substance to actually reply to him, Daryl, other than you think he doesn't understand when you couldn't even define what a postulation was? Do you have
Um,
a substantive response?
I guess I guess I'm used to hearing, like, for instance, real scientists speak about things.
So do
And
you
like, for
have a
instance,
substantive response? I'm not asking what you're used to. Do you have an actual rebuttal or reply to him?
if you will let me talk, I can give it.
Without gaslighting him, do
I'm
you
going
have a
to say what
direct
I'm going to
response?
say, not what you tell me to say. That's not going to happen.
I'm not going to
I'm not
tell
in
you
control
what
of
to
whether you
say.
mute or whatever you do, but
I'm
I'm
just
not
going
going to
to
tell you what you
say.
tell me to say. That's not
I'm
going to
just
happen.
going to say
I'm going
Bro,
to
how
answer
Yeah,
hard is
mine.
it?
you
Just
can't
Google
force
it.
Daryl to say.
Mute
You
this
can't force
dude.
Daryl to
Mute
say
it.
So he
I
muted.
am
So he muted
just
me right
going
there.
to say that a point of moderation, without gaslighting him, do
I'm
you
going
have a
to say what
direct
I'm going to
response?
say, not what you tell me to say. That's not going to happen.
I'm not going to
I'm not
tell
in
you
control
what
of
to
whether you
say.
mute or whatever you do, but
I'm
I'm
just
not
going
going to
to
tell you what you
say.
tell me to say. That's not
I'm
going to
just
happen.
going to say
I'm going to
Why,
answer
that
why
with
does
mine.
he
I'm
just
just
Google it?
going.
Mute this dude. Mute it.
I am just going to say that a point of moderation. I'm not going to allow and continue gaslighting in the room without direct rebuttals to people. So if you're not going to directly rebut him, then I'll just mute you mid sentence. Go.
Again, I'm going to say what I want to say. I'm not going to say what you tell me to say. Now, going back to what I was saying, I'm used to talking to real scientists who, like,
Cool.
I
So does
want to see
anybody
what
else
they
have
say after
anything
this
else
point.
to add to the conversation? I literally just warned him,
Is the one-on-one
and that's
over?
exactly what he did. Yeah, the one-on-one's over because one participant can't
And I'm going to say what I was about to say right there, by the way.
follow basic, simple rules. We don't just sit here and gaslight people and try to go on a tirade as to why somebody doesn't understand. And I'm used to talking to people that are more intelligent than you, thus I don't have to explain anything to you. BS. Go ahead with whatever conversation you guys want to talk about.
Can
Well, isn't that
Dysel
just
go
a
over
red
those
herring?
two?
I mean, right?
Maybe someone should explain him what is a postulate, but then he will start listening.
Yeah.
No,
Is Daryl
because
here?
he's himself that he's not actually here to engage in an actual intellectual conversation. 'Cause typically that's what-
Isn't real science testing like things and like
I can understand, Blue. I mean, this definitely turns me off on the server a bit. Definitely. But you know, there are some good guys there. Uh, uh, you know, I do have some good conversations there. But I do know I'm not going to just, you know, say what they told me to say. That's not going to happen. And if I keep getting muted, then I just won't go back anymore. If I go back even now, but clearly I need to start doing some other things to make content because yeah, what I was going to say there, by the way, is like I'm used to, like I said, going to colloquiums, and I've asked scientists questions, like real scientists, and never have they said, "Well, you explain this to me." No, they just answer the question, you know. And sometimes I'm pretty certain I ask questions that, you know, when you go to a colloquium, it's this PhD usually. I mean, sometimes it's graduate students, but usually there's this PhD, or sometimes it's postdocs. But usually there's this PhD who is like an established PhD. Sometimes it's Nobel Prize laureates, and they did some fabulous research, and they're talking about some high level stuff, like cutting edge stuff, right? Most of the ones I go to is astronomy because that's what I'm most interested in, right? So it's like, you know, they discovered this new type of, you know, star, or they found this new facet of galaxy that has a different metal content, or, you know, that's two things that come to mind. And sometimes they might say things that I'm sure a lot of the scientists in the room already know, but I'm like, you know, what's going on with this, or what's that, you know? And they just explain it and they say, okay, this is what the situation is. That's what I'm gonna say. I'm used to going to colloquiums and stuff where I remember it must be like 10 minutes ago in the talk that I asked the guy to just explain what he meant by what he was saying, that the universe is postulated on either ether or it seemed like he mixed it up. One time he said ether or relativity, and another time he said dark matter or relativity. Maybe he just misspoke over one time and he really meant ether. And he just started asking me about how we learned about ether. When I talk to the actual scientists, they just answer the question. And if I don't understand, they clarify and use a different word. So that's what I was going to say. I'm used to speaking to people who, when you ask them a question, they answer the question, they clarify. They don't tell me I'm denying stuff and then try to press me to answer the question that I asked them to define postulate. Just use a different word, you know, because like I said, I've taken astronomy, I've taken astrology. Astronomy. I've taken not astrology, but astrophysics, stellar astronomy. I meant to say galaxies and cosmology, and I've never heard that type of wordage. Like the universe is postulated and predicated on dark matter, dark energy, whatever it means. I've never heard that verbiage any ever, not from a you know, my professor or people that come from colloquiums. So it's like, what does he mean? What is he talking about? You know, and just in case, let's look up postulate, and this should be pretty much the last thing before I close up. So this is the definition of postulate. Let me bring it down here so I can read it as well. I have the stream on the other window at the moment, my other screen. So it says postulate or postulate, to assume or assert the truth, reality, or necessity of, especially as a basis of an argument. To propose as a hypothesis or explanation. To assume as a premise or axiom, to take for granted. So is he just assuming? Where in the world does science assume that ether or relativity is the basis of the universe? It's not making sense. I don't see where that fits into any cosmological argument. Currently, he's not able to explain. Usually, I find when they're unable to explain, oh, you said ether, all right? So apparently, they're not able to explain. So what they do, they try to press you for questions. And I'm like, look, I've talked to people who actually know what they're talking about, and they don't do this. They just answer the question and don't try to pepper me for questions. So, but I got a few DM from people saying, hey, this Napalm guy is a bad moderator, and he does this to try to shut people up when he know they're about to make a good point. You know, he knew he was going to crush Dicello if you kept talking or whatever, and you know, perhaps. But at that point, I really was just trying to understand what he's talking about. But sure, they're going to go on for a bit. I'm not really sure what they say next.
Constantly like improving and like,
Is there a real
you know,
Glober?
A
What?
postulate is a suggestion of the existence or a fact or a truth based on reasoning, discussion, or belief.
Which perfectly
But is there a
followed
A
Glober?
exactly
system.
what
It's
Geisler was
basically
laying
the
out.
proof, the
Geisler's argument.
suggestion of the proof for something to exist based on a system.
But that still doesn't answer the question. That's what I'm saying. Okay, so where is that what does it mean that the assumption that the universe is based on dark matter, like or ether, like where is that? What does that mean? We understand that dark matter is a component of the universe, which we know from the rotation curves, but we don't think dark matter like made the universe. It's just a fundamental part of the universe. Just like stars are a part of the universe and gases are a part of the universe. They're just a big part of the universe. But what does it mean that is postulated, that is predicated on that? I mean, just I don't know. I don't think he knows. I don't think he could explain. But awesome. It feels like a good place to stop. Thanks for joining, Blue. Thanks for joining everybody else who showed up. It's good to see you again. And what I may do next time, I know I'm going to do another version of you know that Veritas documentary. I just go through like 15 minutes a week, so I'm sure it'll be a while doing it, but I don't want to speed through. It's just so good. And what I'm probably going to do is find some flat Earth videos to debunk, and maybe I'll make a debunk video instead of a conversation video. Maybe I'll make a few debunk videos and spend some time doing that. So if you don't see me before then, you'll see me Saturday evening, and that'll be when I'll definitely make another video. But I'll see if I get another one out before then. So what I'll do, I'll go off camera. I will maybe just let this play a little bit on as an outro, and I'll see y'all next time.
Is there a
Which
Glober
perfectly
though
which
that's gonna
perfectly
step up to
followed
the
what.
plate?
Well, I just want to reiterate that the definition that Arwen just read is a perfectly illustrates exactly what Deisler was trying to put forth. The
Yeah,
gentleman
but we
didn't
all know
understand the
definition.
term, right? But the gentleman claimed to not understand that term, but then went on to claim that Deisler's not qualified to have the conversation for some reason. So let's just
Yeah, I
move
mean,
on, unless
postulates
somebody else wants to.
postulates is a pretty basic. If you're a native English speaker, you should understand what the word postulate means. But is there? This is my question still yet. Is there a Glober who's gonna come up to the home plate? Because it seems the last guy just struck out.
I think we already won the game, honestly, but we're just like,
Well, it's about dark matter, right, guys?
And
What
postulate
is
is not only in English, sorry for interrupting, but postulat is not only in English. So any scientist should know this word.
No, I'm
anyway.
just saying.
Correct.
Just
Yeah,
saying, if
and
you are a
that's
native
why.
English speaker, if you're a native English speaker and you know nothing of science, all you've done is study fucking English and literature your whole life, you would still understand what the word postulate means.
Well, I'm here to
Correct.
learn from you guys. So, but I just get annoyed when guys like that just try to gaslight. So I'm
Dude,
sorry
I need
for.
someone to step up to the home plate.
I
So
gave
that's
you
why
my
I
What?
stepped
explanation.
What do you
That's
need?
why. Hold on. That's why I stepped in to moderate, is because we're trying to avoid that meta conversation of like gaslighting, you don't understand, you don't comprehend, right? The like, oh, that's just word salad. All these things that are said to not actually address what's the actual conversation. So that's the reason for the moderation, in order for a conversation to move forth in a productive manner. So
You did great.
Okay, umpire Napalm, could you get a Glober up to the home plate? Because like I want to see some ball games.
I gave you my definition there. So I gave you my explanation.
Are you
sounds like
stepping?
Omnivore wants to step up to the plate, but just being said, the rules of the
Who's your
game are
Not
still
if
going
I,
to be the same
not
for
if
you.
I'm gonna get muted and
Who's your
warned.
pitcher? Who do you want to pitch to, Omni?
I